Good morning. Welcome to our Week 5 topic on Information Management 2. We have the specialization and generalization, wherein these are the simple inversion of each other. So they are represented in the ER diagram in the same way. So the topic objectives for this week, after the discussion, the students are expected to differentiate generalization and specialization and understand the different database keys. Generalization extracts the common features of multiple entities to form a new entity. So it works on the principle of a bottom-up approach. So in generalization, the lower level, the lower level functions are combined to form the higher level functions, which is called the entities. So this process is repeated further to make an advanced level entities. So in generalization, the process properties are drawn from a particular entities, and thus we can create the generalized entities. So we can summarize the generalization process as it combines the subclasses to form the superclasses. So this consists of the different design constraint, the constraint on which the entities can be the members of a given lower level entity sets, wherein the conditions are defined and the users defined. So for example, all customers over the 65 years are members of the senior citizen entity set, and senior citizen ISA person. So the constraint on whether the entities may belong to more than one lower level entity sets within the single generalization. So we have to use this in a disjoint. So an entity can belong to only one lower level entities. So another example, we have the entity of a person, which is divided into another lower level entity, which is persons and customer entities. How about generalization overlapping? So an entity can belong to more than one lower level entity set. So in the given example on the overlapping, we use the two triangles with the dotted lines to represent that there is an overlapping before the person's entity considered as the employee and the customer entity. So unlike the disjoint, on this example, we only have used the one triangle and the rectangle following the or representing the employee and customers persons. So we have completeness constraints. If we say completeness constraint, this specifies whether or not an entity in the higher level entity set must belong to at least one of the lower entity sets within generalization. If we say total, an entity must belong to one of the lower level entity sets. If we say partial, it is an entity that does not need one of the lower entity. So in the given example, we have the persons as the total entity, and the partial entities would be the employee and the customers. How about the aggregation? Aggregations eliminate the redundancy via aggregations. So we treat the relationship as an abstract entity which allows relationship between relationship, and there is an abstractions of relationship into new entities. So in this example, we have to consider the ternary relationships works on. Yan. Suppose that we want to record the managers for task performed by employee at a branch. So this is the given example. We have the employee entity, the job entity, the branch entity. We have the ternary relationship between or among employee, job, and branch with a relationship of works on. And then we have the branch, which has the relationship of managers to manager. So in this example, the aggregation, for example, on the left side, the relations corresponding to aggregation. To represent the aggregation, we have to create a table containing the primary key of the aggregate relationship and the primary key of the associated entity sets, which is any descriptive values. So in this example, we have the relationship between the three tables or three entities, which are employee, job, and branch. So to represent the aggregation, we put those entities together with the relationship thereon, with the ternary relationship on a rectangle, indicating there is an aggregation among those entities. How about specialization? Specialization splits an entity from multiple entities that inherit some feature of the splitting entities. So the higher level entity must have the lower level entities, and that higher level entity may not have the lower level entities. So which means we can say that the specialization is the opposite of the generalization. Because specializations, the things are broken down into a smaller things to simplify it further. For example, we have the person's entities consisting of the different attributes such as names and birthday. So this would be the specialization, wherein a particular entity sets get divided into the sub-entities, and it's done on the basis of its characteristics. So also specialization inheritance takes place, or the so-called attribute inheritance. The attribute inheritance, known as the lower level entity inherits all the attributes and relationship participation of the higher level entity sets to which it is linked. So it can have the multiple specialization over the entity set based on the different features. So the ISA relationship have referred to us as the superclass or the subclass relationship. So in this example, we have each employee would have a member of one permanent or a temporary. So this member can be an officer, a secretary, or a teller. So that's how we specialize. Means we have to be specific on the details about the entities. How about the database keys? The database keys, we have the super key, which is defined as the set of the attributes with a table that can uniquely identify each record within the table. So the super key is a superset of candidate key wherein it is a group of a single or multiple keys which identifies the rows in the table. So the super key may have the additional attributes that are not needed for a unique identification. So in the given example of our table, the student ID can be considered as the super key. How about the candidate key? The candidate keys are defined as the minimal set of fields which can uniquely identify each record in a given table. So, this is an attribute or a set of attributes that can act as the primary key for a table to uniquely identify each record in a given table. So, there can be more than one candidate keys. So, in our example, we have the student ID and the phone number. So, both are the candidate keys for the table students. A candidate key can never be null or empty, and its value should be unique. So in the given example, the value of student ID and phone are considered unique. That's the reason why they are considered as the candidate key, which can be a combination of more than one column or attributes. So there are different properties of candidate key. So it must be contain unique values, and the candidate key may have a multiple attributes and must not contain null value or null value. So it should contain the minimum fields to ensure the uniqueness, which uniquely identify each record in a table. How about the primary key? Primary key is a candidate key that is most appropriate to become the main key for any table. It is a key that can be uniquely identify each record in the table. So for the table students, we can make the student ID column as our primary key. How about the composite key? The composite key are keys that consist of two or more attributes that uniquely identify any record in a table. So, but the attribute which together form the composite key are not key independent individually. So, in this table, the student and the subject code together will form the primary key, hence it is considered as the composite key. So we have two primary keys, but it was considered as not primary key. Instead, we use the word composite key to define that the seed and the subject code are unique keys. The secondary or alternate key. The candidate key, which not selected as the primary key, are known as the secondary keys or alternate keys. The alternate key is a column or a group of columns in a table that uniquely identify every row in that table. So a table can be a multiple choices of primary key, but only one can set as the primary key. All the keys which are not primary key can be called as the alternate key. So in this example, we can identify that the student ID is the primary key, though there is a roll number or an email here that can be considered as the unique uh, identify or uniquely identify every rows in a given table, they are just considered as an alternate key or the secondary key. How about the foreign key? The foreign key is a column that creates a relationship between two tables. So the purpose of foreign keys is to maintain the data integrity and allow navigation between the two different instances of an entity. It acts as the cross-reference between two tables as it references the primary key of another table. A foreign key cannot automatically create an index or a clustered of index and non-clustered. However, you can manually create an index on the foreign key. So it is a field in the table that is the primary key of another table. So meaning a foreign key may accept multiple null values. You have multiple foreign keys in a table. To summarize our lecture, the generalization versus the specialization, in generalization process, what actually happened is that it takes the union of two or more lower level entity sets to produce a higher level entity sets. So the difference and similarities between the lower entities are ignored to form a higher entity. So there is no called as inheritance. It applies to group of entities and the size of schema gets reduced and works on the bottom-up approach. If we say specialization, it is the process of taking a subset of a higher level entity sets to form a lower level entity sets, meaning a higher entity is split to form a lower entities. There is an inheritance and applied to a single entity. The size of schema gets increased because we are discussing it on a detailed approach. It works in a top-down approach. And to identify the different database keys, we have the super key, the primary key, composite key, the secondary or alternate key, and the foreign key. These are the references that you may use for further readings. Thank you and good morning.